This video is going to be about molecular geometry. So before we actually learn about all the shapes, we have to know what the electron domain is. So basically, an atom's electron domain are the lone pairs or chemical bond locations that surround it. This represents the number of locations expected to contain the electrons. And then, so finally, you can use the electron domain to predict the molecular geometry. So in this example, if you count the electron domains, there's going to be one here, one here, one here, one here, because those are three bonds. And then there's also going to be one here and one here. And those are the electrons not bonded. Alright, so once you find the electron domain and how many electron domains it actually has, you can find the molecular geometry. So when you count two electron domains, it's always going to be linear. And then for a linear, there's only going to be one molecular geometry, and it's going to be linear. And so I'd say linear is the easiest one to remember because there's only one molecular geometry for it. And the molecular geometry name is the same as the electron domain name, just linear. And then this is where it starts to actually get confusing. When you have three electron domains, it's always going to be trigonal planar. And so for trigonal planar, there's going to be two different molecular geometries. There's going to be the trigonal planar, and then there's going to be the bent. And then trigonal planar is going to be when all the electron domains are bonded. So like in this example, you can see that all of them are bonded. And the bent is when you have one lone pair of electrons which is not bonded. So like here it's bonded, here it's bonded, and then right here this was where the two electrons would go, and they're not bonded to anything, and so that's when it's going to be bent. Alright, tetrahedral is when you have four electron domains, and so tetrahedral is going to have three possible molecular geometries. There's going to be the tetrahedral, which is going to be when all of them are bonded together, like this example right here. Trigonal pyramidal, which only has one non-bonding pair. And then bent is when there's going to be two non-bonding pairs. Alright, for these next two slides, they only apply when there's an expanded octet. So when we had a tetrahedral, there were four electron domains. So most of the time that meant there were 8 valence electrons. But for the next two slides, there's going to be more than 8 electrons. So trigonal bipyramidal is when you have 5 electron domains, which is going to be more than the 8 valence electrons that it's supposed to have. And so for trigonal bipyramidal, there's going to be 4 different molecular geometries. There's going to be trigonal bipyramidal, which is when all of them are bonding. Seesaw is going to be when one pair is non-bonding. T-shaped is going to be when 2 pairs are non-bonding. And linear is going to be when there's 3 pairs not bonding. I'd say trigonal bipyramidal is the hardest one to memorize because there's so many different molecular geometries. But once you get it down, it's actually not that bad. And then this is the last one. This is octahedral. And octahedral is going to be when there's 6 electron domains. It's going to be the most there is. And there's going to be 3 different possible molecular geometries. There's going to be just the octahedral, which is when all are bonding, square pyramidal, when there's one non-bonding pair, and then square planar is when there's going to be 2 non-bonding pairs. And I'd also say this one's pretty easy to memorize. You just need to know that there's 3 different possible molecular geometries. One of them is going to be the same as the electron domain name, octahedral, and the other 2 both start with square. And the first one you just have to remember is pyramidal, the second one is planar. Pyramidal is going to be when there's one non-bonding pair, and planar is going to be when there's 2 non-bonding pairs. And so in order to actually understand these, you're going to have to continually study these terms. So these are right here, these are the electron domains that you count. Right here is going to be the lone pairs, and then right here is going to be the bonding pairs. And then you can ignore this column right here over type. And then here's going to be what the electron domain geometry is going to be. Here's what the molecular geometry is going to be. And then this is going to be the these are just examples. And you can ignore this row right here about octahedral and linear. So you really have to study these terms in order to better understand this concept.